What's up, guys? Back today with another tutorial. Today we're going to be learning about Caesar ciphers. So what is a Caesar cipher? A Caesar cipher is a shift cipher used in cryptography and encryption. So how does it work? Each letter has a corresponding number value. So let's say A is 0, B is 1, C is 2, as shown here. And then it takes a shift value and applies it to the letter. So shift plus 2. So then C would go to 4, B would go to 3, A would go to 2. So let's say you have a word that you want. You have like code. Well, then the C in code would get shifted plus 2 if your key was 2 to 4. So then it'd be 0, 1, 2, 3, 4. So then your first letter in your new encrypted word would be E. This is a very basic cipher and is used in very basic cryptography. And this will make more sense as we get into the coding part. So let's get into it. Okay, so to code our Caesar cipher, first we're going to need to grab some input from the user. So we want the coded phrase. So I'm just going to say text equals input, and then please input your phrase. Then we're going to want the shift. So we're going to say key equals integer input your shift. So next, I'm going to make an empty string, call it result. This result will be used to store our final encrypted message. So now we're going to need a quick for loop. So for I in range length of our text. Then we're going to want a quick if, or we're going to define a variable first. So char equals text I. So char is just going to represent each letter in our string. So then if char dot is upper, so this is going to check if it's uppercase. And then we're going to say result plus equals char ord char plus key minus 65 modulo 26 plus 65. Now what this is doing is it's checking if the character is uppercase because the Unicode will be different for the uppercase letters. So Chrome, or the CHR right here, is going to take our Unicode and convert it to the string letter value, or just taking the char or character and converting it to a Unicode. So Unicode plus key minus 65. The reason that we have these numbers is because our capital letters start at Unicode 65. So what this is going to do is, let's say our letter is B and our shift is 1. So B plus 1 minus 65. So it's going to be negative 1. So B is 66. So 66 plus negative 1, 64, modulo 26 plus 65. So 66 plus or minus 64 is going to get 2. 2 modulo 26 will be 2, because 2 divided by 26 is going to have a remainder of 2, plus 65 is going to get 67. So 67, that would be C shift down 1. So now we're going to write an else statement for our lowercase letters. So else result plus equals ord char plus key minus 97 modulo 26 plus 97. And the reason we have 97 for this one is because our lowercase letters start at the Unicode 97. So this does the exact same thing, just with lowercase letters. So now we're going to want to print out our answers, or our final results. So print, I want the key printed, so I'm going to say key plus string key, and then print original plus text, and then print encrypted plus result, because our result is going to have all of our encrypted values in it now. So if we run it, let's say our word is code. Input your shift 10. Code moves to set to. Okay, so one thing I forgot to do real quick is this is upper. This is a method, so it needs those. So now it's going to actually check it. So input your phrase, code, input shift 11. And there we go. We got our original message, our key, and our encrypted message. Caesar ciphers are very useful if you want to transport information, but you don't want other people to see it. You can give your friend, whoever you're sending, the key, and therefore the people who are looking in will have an extremely hard time of decrypting your message. I hope you guys enjoyed the video. I'll see you guys later, and yeah, bye.